Hello viewers. In today's video, we are going to design an RCC spiral staircase. Just click on the STAAD Pro interface. Here you can just select the space unit and click on next and just click on the add beam option. If you finish, just click on finish. After this, you will find the interface of the STAAD Pro. Here we are going to use the STAAD editor to assign the points over here. Just click on this STAAD editor. Here you can see this is the STAAD editor. Just click on STAAD editor. Here you find the STAAD editor. Just click on this end job information. Just click here, enter. Just enter here, and from here you will get to assign the points which we are going to give there. The first point starts from my 0 because 0 is my coordinate. So just click on first unit we are assigning going to unit assign. So first is meter. Meter after meter just kilonewton. As you know, you can find here meter. You can just select here meter or just write the M over here and just the KN. KN is for the kilonewton. After this, after this we are going to assign the joints coordinate. Just click on this joint coordinate. You can find the option over here directly. Just the go for the cylindrical reverse. Just click on next. Here we are going to give the point. This is the one is in the x-axis, y-axis, then 0 and 0. After this, other one is 24. This is the first coordinate, and this is the last coordinate. 24, 1, 3, 360 is the spiral degree angle we are going, and 21st is the second coordinate of the side. Other one is last is the 48, 3, 3, and 360. 360 is the angle in which we are going to assign the spiral case over here. Just save this, just save this information and just close the STAAD editor. After closing the STAAD editor, you can find the spiral case has been designed according to those. Not the spiral case, you can just find out the coordinates over here, just notes for the spiral case. If you just find out the notes over here, here you can see just compress this shift plus N so that you can find the node numbers over here. If you just press the shift plus N, you can just see you can find the node number over here. In this node number, just select here. You can see the first is the node number and the 24 is the last node number. And when you just find this is the last node number on the second side. If you just find over here, just you can see 25 is the first number which from where we have started. Here, this is the space editor. If you want to see the use of a space editor, STAAD editor, I can just provide you the video over there, how to use the STAAD editor over there, how to assign, how to use this. I can provide a special video over there. Here you can see the 25 is the first coordinate and 48 is the last, and here 1 is the first coordinate and 24 is the last coordinate over here. You now you can see this from the top view. It will look like this. After this is a up, just go and click on this so that we can select the fill plate solid surfaces so that we can differentiate between the plates. Just click on OK, apply, and OK. And now we are going to give uh, just click on the add mesh. Just first select the 26th node. After that, second, this is how to add the plate over here. Just do not make mistake while assigning the plate. Just just make the diagram according to you. Just click on 26. First is the 26th node. If you want to start with 25, you can start with 25 also. Just 25, 1, 2, and 26. Just assign this. After this, click on quadrilateral meshing. Here you can do as per your division. Here I can show you this is the 10 division, but I need just only 5 division per plate. So I will change this. Just here you can see in the quadrilateral, I'm just giving the division over the 5. Here you can see just I'm changing the division to 5 in all the AB, AC, and AD all direction. Here you can find out this. These are the plate. These are the plates. Now similarly we are going to assign all those plates. This is the top view over of these plates, how this look like after creating. Now for the second, here it asks for the save, auto save, and now here you can see in the second plate, this is the top view. If you see the plate from the top, it will look like this color. If you see the plate like from the bottom, it will look like gray color. That totally depends on you how you want to see. Similarly, for the second plate, just select the nodes from 27, 3. This is the second node, and this is the 26th node. And just similarly, quadrilateral meshing, click on OK. After that, provide the division over there. Just provide those division. Click on Apply. Just click on Apply. You can see the second mesh has been created. Just control. Similarly, I have created all those after you have created those meshes. You can see here the all the meshes has been created over here. This is the last one I am creating right now. Just create and provide the quadrilateral meshing. Just so last is the 5 to the division and click on apply. As you can see, I have created those spiral meshing. This is a spiral staircase. Now we are lately we will assign those properties and other things which are required over here. And similarly, you can just see the diagram here. You can see in the 3D view. If you want to just click on this 3D rendering view, you can find the model in 3D rendering view. It will look like this in the diagram. And now after this, if you just remove those platings, you can just see the nodes, and you will just remove the color. You can see how this is look like. Just click on the fill plate. After this, now we are going to assign the support. Just click on support journal. Just click on journal. You can find over here. Just click on geometry. You can just find all those parameters which we all want to design. We are going to assign those surfaces. Just click on journal, click on support. Just click the fixed support. After creating the fixed support, just select the support and select those nodes on which we are going to assign the support. So just select all the nodes at the bottom and at the top of the spiral staircase in which we are going to assign the support. Just after selecting, just click on assign to the selected nodes. Here you can see to assign the property of whole structure, just click on the thickness. I am going to provide the thickness of 0.25 meter over here. Uh, yes, 0.25 meter over here. Click on add. Just click on the select plate cursor. Just select all plate and assign to the selected plate. Here you can see I have provided the thickness to the whole structure. And now if you see this in 3D rendering view, you can find the thickness over here. Here you can see the thickness which I have provided over here. Now close this, and after this I'm going to provide the loads over here. Dead load, live load, we are going to assign those loads. Just click on load and definition. After this load and definition, click on load case details, click on add. Here first I'm going to provide the dead load, change the title to dead, click on add, and similarly select the live, change the title to live, and just close it. In the dead load, first we are going to assign the self weight of the structure. It is the -1 over the y-axis, global y-axis. Just click on add. Just click on add. After that, we will going to provide the plate load. First, I have provided those self-weight load. Just click on add. After this, click on the plate load. Here, I'm going to assign the load of 1.5 kilonewton at the z-axis. Here you can see I have provided over the z-axis. Similarly, if I am going to assign this, just click on assign to the view. For the PR, similarly, just select and assign to the view. Here you can see that I have provided the dead load over the whole structure. After that, for the live load, just click on live and edit this. Just click on edit, yeah, click on new. After you click on new, you just have to provide the plate load. I am providing here 1.25 kilonewton at the z-axis. Click on add and close it. Assign to the view. After that, you can see we have assigned the dead load and live load. Now I have to see where is the direction of the load. It is downward acting or it is upward acting. If I am zooming, just click on apply. Here I am going to apply the pressure first. Yes, yes. Just you can see just after clicking on this, I am going to assign the pressure. Just change the pressure over here. You can see I am changing the pressure to 0.0002 Newton per millimeter square. Here you can see just changing the pressure. After changing the pressure, I am going to apply this over the whole structure. You can see that I have applied the pressure over here 0.02. After just check out what is the direction of load. Here I am zooming the structure. You can see the direction of pressure is from downward to upward. Here you can see, but this is the reverse direction. So I need to just change those. Just click and provide the minus sign over the load which I have provided. After I have provided the minus and you can see the direction of the load has been reversed, and this is the correct direction where I want to apply the load. After this, just click on analysis, click on add, just click on add to the command. After this, when you just click on the add, you can just save the structure and click on run analysis. After the you run the analysis, you can find that I have not get any single error warning or note over here. Just you want to see the output file, click on view output file and done. After you make this, you can see whole points has been given to your idea, which you have provided the coordinates, all those coordinates you have provided over here. You can find all those plates over here, which you have provided over there. Here you can see number of joints, number of members over there. All those things you have provided, you can just find over there. If you want to see the post-processing of this structure, just click on the post-processing. Here you can see whole the structure, how it is looking likely. If you want to just see the animation for this, just click on animation, click on deflection and apply. You can see a minor deflection over here. You can see this. Here is the minor deflections over the whole structure. Here you can see the deflection. Here you can see also the deflection. After this, just nothing. We can just see the structure over here in the 3D view. You want to just click on the 3D rendering view. If you want to see the plate stress over here, just click on the plate stress, click on maximum absolute. Here at the top of the structure, you can see it has the maximum absolute value for the whole structure at the top, at the bottom, in the middle of you can find it normally. If you want to generate the report, just click on report section. If you just want to just take the structure of if you need the picture of structure over this report, you can just find out there. You can just generate take the pictures over there. After this, just go on to the report. You can find here. You can see I'm taking the pictures. I'm just removing all those loads and structures, plate, removing the plate, taking the picture of here whole structure. Here you can see if you want, if I want to see, if I want to take the picture of a section also, I can take a picture of section also. I'm seeing over the rendering here. This is the bottom view of the structure. If you want to see, this is the top and bottom. The change in color you can see. This is the top and bottom of the structure. After taking the picture, if I going to generate the report, just see. After I'm not just analyzing the report again, I'm just showing you that I'm not getting any error after making a few changes anything else. Okay, just see in the post processing section, just go for the report. I am selecting for the output of the structure. Just you can see here I'm going to change for the not the input. We have to change for the output for the section. First, these are the pictures which I have taken over there. If you want the input, just select the to the output. I am selecting all of the currently right now. I will select all. But if you need something special, you can just select those one and you can make the report for that. Here you can see this is the report has been generated over here. This is the report over generated. If you want to just print the report, just click on print section. Here from here you can just print this section. Just click on print. Here you can see all the pages which I have given diagrams and the other report. Just save to the Adobe PDF file. If you need to take the print, you can take the print also. After it will take some time to generate the report as per the structure. My sometime it create report earlier. So after just creating the structure, you can see this is generating my pages for the report. Almost 190, 197 pages for this report here. Here you can see it will automatically open the report after generating in the Adobe file. Here, just wait for a second. I will show you the report also how it is look like. Here you can see that I have provided the report here. These are those sections in which you have to provide all those things. Uh, Name of the engineer, date created, all those things you can find here. You can see that dead load, live load at the particular nodes. After it has 197 pages, so I can't explain each and every page what is there. But you can see at each and every node it is showing the shear bending moment also. E- Thank you for watching the video. I hope you like the video. Kindly subscribe the channel and share the video as much as possible. Thank you.